myself, Dr. Sushma Jain, Associate Professor Chemistry, Government Dungar College, Bikaner. Today, I shall discuss about the von Richter rearrangement in aromatic nucleophilic substitution. This topic is in Unit 3, Paper 2nd, M.Sc. Previous Chemistry. When aromatic nitro compounds are treated with cyanide ion, the nitro group displaced and carboxyl group enters always to the ortho position to the displaced group. This reaction is called von Richter rearrangement. This rearrangement is demonstrated by this equation. In this reaction, NO2 group is the leaving group and CN is entered to the ortho position to the leaving group NO2. So this compound carboxylic group added to the ortho position to the nitro group is formed. This is an example of Cine substitution. The reaction gives best result when the group Z is electron withdrawing group and it is present at the ortho or para position to the leaving group NO2 group or other group. So the reaction is accelerated by the presence of electron withdrawing group at the ortho or para position. The reaction is not generally synthetically useful due to low chemical yield. 37% yield is obtained and numerous formation of side product. So this is not generally synthetically useful. Reaction can be inhibited by the addition of potassium ferricyanide and sodium sulfide. Now, what is the mechanism of von Richter rearrangement? Mechanism was proposed in 1960 by Rosenblum on the basis of isotopic labeling experiment. He used the 15N labeling experiment for determination of the mechanism. In this mechanism, the Cn minus is nucleophile and here this is the para-nitro aryl bromide. This is the substrate and due to more electronegativity of oxygen than nitrogen, the bonding electron displaced to this nitrogen to this oxygen atom. This nitrogen gets positively charged and this get negatively charged, and due to this is more positively charged, it pull the electrons from the benzene ring and the benzene ring electrons comes to this carbon atom and the bonds formed between this carbon to this nitrogen atom and this carbon atom becomes positively charged. This Cn minus nucleophile attack to this positively charged carbon atom and add to this carbon atom and we get the another molecule of this type. Here Cn is attached to the carbon atom and O becomes negatively charged. This O becomes also negatively charged. Now the reaction of this molecule with water molecule, the Cn abstract proton from water molecule and before abstracting the bonding electrons displaced to carbon to nitrogen atom. So this carbon becomes positively charged and this nitrogen becomes negatively charged. So this nitrogen abstract proton from the water molecule and here this is the O minus of the nitro group. So this O minus attached to this carbon atom. OH is removed as OH minus. So we get this type of the structure. The OH minus removed from the water molecule further attack to this proton and removed hydrogen as a proton, and water molecules is comes out from the here. And when this water molecule removed, the bonding electron comes to this carbon atom. So this carbon atom has two electron. Here this nitrogen is positively charged, so bonding electron displaced to this carbon to this nitrogen atom. So this carbon becomes positively charged. This positively charged carbon and this negatively charged carbon atom forms the covalent bond, and this nitrogen becomes neutral. So we get this type of the structure. Now in this structure, the bonding electron delocalization takes place. So the here the lone pair of electron present on oxygen atom forms the bond between the nitrogen and oxygen atom. This bonding electron displaced to this carbon and this oxygen atom, and this bonding electron displaced to this nitrogen atom. So the ring opening is takes place here, and we get the another open ringed molecule orthonitrosobenzamide. Anion is obtained here. The anion of orthonitrosobenzamide is formed here. Then the reaction of this orthonitrosobenzamide anion with water molecule, here the electron displacement of bonding electron to nitrogen to from nitrogen to oxygen atom. So nitrogen gets positively charged and oxygen gets negatively charged. So the negatively charged oxygen react with hydrogen and form and abstract the hydrogen, or we can say proton from the water molecule, and form the OH. And here this nitrogen becomes positively charged, so here negatively charged nitrogen forms the bond with positively charged nitrogen atom. So we get this type of the structure. Now the OH minus which is removed from this water molecule, this is the OH minus, this attack to this NH and abstract the proton from the this NH and forms the water molecule. So here the water molecule is eliminated, and the bonding electron between this nitrogen and hydrogen electrons go to the this nitrogen atom. So this nitrogen becomes negatively charged, and here this OH is removed with its bonding electrons. So nitrogen gets here negatively charged, positively charged, and this gets negatively charged. Here due to hydrogen removed as a positively charged, so the nitrogen has two electrons, or we can say the negatively charged nitrogen atom here, and this becomes the positively charged nitrogen. The positively charged nitrogen and negatively charged nitrogen forms the double bond. So we can get this type of the structure which contain the double bond between the nitrogen atom, and we say this compound is the azoketone. This is the azoketone, this is the ketonic group, so we can say azoketone. And the reaction of OH minus to this azoketone, here the electron displacement from this carbon to this oxygen atom, carbon becomes positively charged, oxygen becomes negatively charged, and the OH attack to this positively charged carbon atom and form this type of the structure. Now the ring opening is takes place here. By here the bonding electron displaced to this nitrogen atom, so N becomes minus, and the lone pair of electron present at this oxygen atom form the double bond between this carbon atom, which becomes the positively charged by the removal of by displacement of the electron from this carbon to this carbon atom. So positively charged carbon and negatively charged oxygen forms the double bond. Here this form the double bond, and N becomes negatively charged. Here the N becomes negatively charged and we get the carboxylic acid containing the diazo group. Here by elimination of the nitrogen atom from this N double bond N, we obtain the carboxylate anion of aryl halide, and which on protonation gives the carboxylic acid. So by this long mechanism, the von Richter rearrangement can take place. Now what is the evidences of this mechanism? In this mechanism, the nitrogen is major product of the reaction. This indicates that nitrogen-nitrogen bond must be formed during the course of the reaction. And the second evidence is that the subjection of independently prepared orthonitrosobenzamide and azoketone intermediate to the von Richter conditions, we obtain the expected product, which can we can say the von Richter product obtained by the subjection of the independently prepared orthonitrosobenzamide or azoketone intermediate. So these evidences support the mechanism of the von Richter rearrangement. Thank you.